In this video, I want to give you a sense of the way that we can use table A3 to find the critical value for a confidence interval. So that's the whole point for the time being of using table A3. It is to it's for finding the critical value. There are two critical values that we've used so far. The first was z sub alpha over 2. This is if we're using a normal distribution. And t sub alpha over 2. This is if we're using a T-distribution. If we're using a normal distribution, the procedure is relatively straightforward. We've mentioned this in the past. Based on the confidence level, so based on the desired confidence level, we pick one of these rows at the bottom, one of the columns at the bottom. So if we're interested in a 95% confidence level, this column is all the values related to a 95% confidence level. For a normal distribution, we'll be using this row labeled z. So if we wanted the confidence level, which on the calculator they call the C level, to be, so if the confidence level is 95%, then z sub alpha over 2 is, looking at our chart, this 1.96 that we've seen before. If, on the other hand, we're trying to compute the confidence level on a T-distribution, we also need to know the degrees of freedom. And we've talked about that before, but one important thing to notice is our degrees of freedom in the table start at 1, and it counts by 1s all the way up to 40. And then from 40 it skips all the way to 50, from 50 to 60, to 80, to 100, all the way to 200. So what happens if your degrees of freedom turns out to be something like, I don't know, what if it turns out to be 57? So this would occur in a situation where the original sample size was 58, we subtract 1 from it to get 57 for our degrees of freedom, and if we look at the table, there is no row 57. So which row are we supposed to use? Well, in this case, we have to round down to row 50. And the reason for rounding down is similar to the reasons we've talked about rounding previously. We want to round in a conservative direction. We know that a larger sample size is generally better. So I can't round up to 60 and say, hey, I have a degrees of freedom of 60, which is like having a sample size of 61, when the reality was we only had a sample size of 58. We had a smaller sample size. However, by rounding down, we're saying, hey, we're treating this as though we really just had a sample size of 51. We really actually had a sample size of 58. So the results we get are actually going to be better than the ones that we compute. So we're this is the same idea. Under promise, over deliver on the results that we're getting. It's okay to claim that we're using only 51 as our sample size if we're really using 58, because that means we're doing better than what we're saying, but it's not okay to say that we're using a sample size of size 61 if we're only using a sample size of 58, because in that case we would be claiming to get better results than we're actually getting. So in this case, we'll round down to 50, and that means that we will use this row here. Again, we said we were going to use a 95% confidence level, so 95% confidence level, the row labeled 50. Where do those two numbers meet? 2.009. 2.009. And that would be the critical value that we would use. The last thing to note is if our degrees of freedom is greater than 200, notice our table stops at 200. If it is greater than 200, we will just use the row that's labeled Z and treat it as though it were a normal distribution. And that is how we will wind up using table A3.